Exercise 5 is a little bit tricky. This is the Fibonacci sequence. So if you know it, then you know it. If not, it looks pretty complicated, right? It has all these F's and N's, and this is basically what's going on. It tells you the first two numbers, right? That's pretty clear here. This is the first term. This is the second term. It's F sub 2. They're both 1s. But the sequence isn't all 1s. It says after that, any function value can be found by taking the one that just came before it plus the one that's 2 before that. Okay, so if I'm interested in F sub 3, it's going to be F sub 2 plus F sub 1. And of course that's just 1 plus 1, so that's 2. Why don't you see if you can work out F sub 4, 5, and 6. I hope you took time to do that. So F sub 3 is now found to be a 2. We're going to add 2 plus 1, now came out 3. Okay, do you see where I'm getting that 3 from? Because F sub 4 we already found, came out to be a 3. F sub 3 we already found, came out to be a 2, so I'm just adding the 3 and the 2. If you haven't done any yet on your own, stop and do this one on your own. Then play the recording when you're ready. So hopefully you paused and worked this out. If not, what are you doing, right? You're wasting your time. You're just writing down stuff and not getting anything out of this. So pause and figure this out. Okay, so if you figured out F sub 5 we found to be 5, F sub 4 we found to be 3, so you're just going to add up the 5 plus the 3, and you've got an 8. You can kind of see what's going on, right? It sounded like it was first all going to be 1s, but then it was 1 plus 1 is 2. 2 plus 3 is 5, right? Right, so it keeps building on that. 1 plus 2. So the sequence looks like this. 1, 1, 2, 3, 5, 8. Can you guess the next term? 13, right? Because it's adding. Can you add the next term? 21, right? Because it's adding the previous 2, and so on. Cool. All right, guys, so this following part, let's see if you can work this out. Let's see if you can come up with as many of these formulas as you can. I'm going to change the notation on this. I want you to cross that out and make it A sub n, because that's what it says in exercise 1, just so we're consistent. Not that we couldn't use a function notation with an A in front, you can, but let's just be consistent with what we had in exercise 1 so there's no confusion. Because the notation is critical that you are comfortable with it here. So pause the recording, work as many of these out in exercise 6 and 7, then play the recording and I'll show you the answers. Okay, so if we work these out, if not, please do. This first one, I can see the pattern is it goes up by 1, but it starts at 4. So I'm going to write it this way. A sub n equals start at 4 and add 1 how many times? Well, it's always 1 less than the term that I'm trying to find, right? So if I'm trying to get to the third term, I added on 1. So the third term would be 6. Added on 1 twice. It's always 1 less. So n minus 1 amount of times. Okay? This one is a pattern of multiplying by 2. So I'll start with 2, that's the starting amount, and I'll multiply by 2. It kind of looks like an exponential function. But I'm going to multiply 2 by 2 n minus 1 amount of times, right? Because if I want to get to the fourth term, I would have multiplied by 2 1, 2, 3 times. So it needs to be 1 less than the term number. Here you can see the pattern is the numerators are all 5s. There's got to be a 5 involved. The denominators are the n's, right? I could really put this 5 over 1. Next one, this is kind of a tricky one. The signs are oscillating. Negative, positive, so the first one has to do with an exponent, right? So think about it. All right, well, let's say the first one has to be a value of 1 as n. So would that get me what I want? Well, yeah, that would come out to be a negative 1, and the next one would be negative 1 squared, so it would be positive. The next one would be negative 1 cubed, So that would be negative again. Looks like it's working. This one, again, it's as a starting value of 10, so I'll write that down. And then what's the pattern? Is it a multiplying pattern or an adding pattern? Well, it looks like it's an adding pattern of 5. So the question is, well, how many times am I adding 5? If I want to get to the fourth term, I would add 5, 1, 2, 3. So it's n minus 1 amount of times. And if you're wondering, well, can you distribute this out and write it in like y equals mx plus b form? Sure you could. You could write it out as 10 plus 5n minus 5, distributing, and then collect the like terms. So I could essentially write it as a sub n equals 5n, and then add those and get a 5. This is essentially the y-intercept of a graph of these points if I were to extend the domain to be n equals 0, which is not part of a sequence. I would be going 1 to the left. It would be a 5. Do that similarly here. This would work out to be the same thing. And finally, it's the pattern. The denominators are all squares, including the first one. So 1, 4, 9. The numerators are all 1s. So it's n squared. And finally, the graph at the bottom, well, the ones that have continuous functions as opposed to discrete. These are discrete. All right, this one and this one. And these other two are called continuous because they're connected. Continuous doesn't make sense here because the domain is just the positive integers, the natural numbers. 1, 2, 3, 4. And so here it doesn't work because the domain is including 0. So the domain is the positive integers. And so when I sub in a positive integer like 1, I get 3. That matches. When I sub in a 2, 2 times 2 plus 1, 5. So that matches. So it looks like choice 3. Thanks for watching.